You're listening to The Skeptic's Guide to the Universe, your escape to reality.
Hello and welcome to The Skeptic's Guide to the Universe. Today is Wednesday, August 27th, 2025, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, everyone.
How's everyone doing?
Quite well, sir.
Quite pretty
Okay.
good. So, Uranus has a new moon.
Oh, congratulations.
How'd you say
Way
that?
to go, Uranus.
Uranus.
It's new?
Yeah, it's brand new.
Well, newly discovered moon.
I see.
Newly discovered moon. This is the first moon discovered around Uranus in 40 years.
Oh, wow.
Which brings the total count up to 29.
29.
Does not have a name yet, just a designation. S/2025U1. First Uranus.
It's what, 6 miles wide?
6 miles, yeah. Very dim, which is why it wasn't seen by previous probes
Sure.
and telescopes. They were looking for, I think, for shepherd moons, because, Uranus has rings, and the rings are tidy. They're not spreading out. So they said there must be some shepherd moons gravitationally keeping them penned in.
I see.
So that's how they found this moon. But it's actually not a shepherd moon, though. It's not where it would need to be. It's a little bit too far out. But still, they were able to see it.
These ring particles will never deorbit and land on the
I don't
planet?
know. I was thinking that, too.
Is that the Roche limit?
Yeah, so if it's too close, they rain in. If they're too far out, they drift away, unless you have shepherd moons keeping them in place, I think is what happens.
Interesting.
It's between the moons Ophelia and Bianca. You know where those names come from?
Some reality TV show,
I
right?
think, right?
Shakespeare? Yeah,
It's all Shakespeare.
Yeah.
Yep,
Yeah.
it's all Shakespeare. Puck is also around Uranus.
Oh, interesting.
Yeah.
Look at that. Juliet,
Mm-hmm.
Portia,
So,
definitely.
has anyone just directly called out the idea that Uranus has a different way of saying it that means something, and people laugh at it? But why?
Uranus?
Yeah, the point here is where'd the name come from and why?
It's a god.
But then at some point in the English language, people came up with your anus and
Yeah, what came first, Uranus or anus?
Yes, exactly.
Well, but even if you look at how it's spelled, it's got the word anus in it.
It does.
Yeah, so I think that was always going to happen. Even if it was always pronounced Uranus.
I don't think it was.
Uranus.
My memory is that it was Uranus, and then eventually that kind of transitioned to Uranus, which I'm totally fine with. That's fine. Uranus
Triggers the giggle.
But I mean, it's a Greek god, so do we know how it was pronounced?
I think that, hey, maybe that'd be good. What's the word, Kara?
Yeah, do
well,
we even
they
know
were
how
speaking
ancient
Greek back then, but
Yeah, but it's ancient Greek.
Yeah,
Oh,
god
gosh, we need
of
a
the
Rosetta Stone now to
sky
figure
and
this one out.
heavens.
Well, that maybe to
Husband
some
to
people.
Gaia.
Yeah.
All right. Well, it's a weird and funny coincidence that young people through the ages have been laughing at.
Oh
Well-
so apparently,
Yeah.
the I think the other spelling is Ouranos.
Oh.
Oranus.
So you're basically
Oranus.
saying, "Oh, Uranus."
Oranus.
And when you go to Merriam-Webster and you look at the pronunciation, they say both Uranus and Uranus.
Great.
Yeah.
and of course, the cartoon Futurama fixed it 1,000 years in the future. They renamed it to Erectum.
Rectum damn near killed him.
So you guys, it just reminded me, I've told you guys before, I've been in this on again, off again, debate thing going on with this chiropractor that I used to be friends with.
Mm-hmm.
And again, I mean, I'm sure he's a nice guy. I knew him; he was a good guy. I don't want to cross those wires, right? But I've been heavily debating him and calling him out and his profession out in crystal clear terms, and just really saying the hard stuff to say to someone whose career is dependent on something that I personally believe is complete and utter nonsense.
Jay, can you give us a little background? Is he a reform? I mean, is he?
He's a straight chiropractor.
He's a straight,
which means he believes in the magic.
Subluxation.
Yeah.
theory.
Yep, innate intelligence and life force and all that.
Okay, so he's deep
blah,
in.
blah.
Yeah.
What year
Yeah.
is it?
So I have to tell you, and I thought of Evan, of course, is that I actually sent him a post, a very heavy post, and I sent him the meme. You have a degree in baloney. The guy runs up. I have a degree in chiropractic, and then the guy yells, "You have a degree in baloney," and I actually sent that. I couldn't help myself. It was perfect for the situation.
But in Futurama, he says, I have a degree in homeopathy.
Yes.
And he says, you have a degree in baloney.
Oh, it wasn't chiropractic. I sent
No,
him
It was homeopathy.
I sent him that anyway, and he knew it.
Chiropractors learn homeopathy.
Right. Yeah,
Chiropractors are the most common prescribers of homeopathic remedies in the United States.
Yeah.
There you go.
And, he another few interesting details, because he was literally arguing that they can prescribe medicines and stuff, and they can perform surgery. And I was just like, this is all fantasy.
Surgery.
They can prescribe like a couple of things other than, vitamins. And like, you can't even call what they do surgery. You know what I mean? Like it isn't like what
I've never heard of them doing.
But it can cause
They
a
do
lot of harm,
procedures.
as
Yeah,
we often say.
absolutely.
And you guys know what the most common fatal chiropractic injury is?
Is it dissection?
Yeah, dissection of the vertebral artery. I
Vertebral
think.
dissection.
So basically, that
and-
means that they tear an artery in your neck.
In your neck.
That means you bleed out like in a very short amount.
No,
of
it doesn't
time.
mean you bleed out. It means you stroke out.
You stroke out.
Yeah.
And that actually happened to a friend of a friend who is in her 20s.
Oh my gosh. That's awful.
It's always so tragic because it's mostly young, healthy people who just have like these worst possible strokes. Yeah.
And then they go ahead, the chiropractor will
man.
blame the incident that took place before, which brought them to the chiropractor right ahead of time. And, it was your original injury. It wasn't me that did this.
And so my friend has a rule now whenever people in her life or like people that she cares about tell her, I'm going to see the chiropractor for my back. I'm going to, she tries to tell them, don't do it. Like, don't go see the chiropractor. But she's like, you know what? Whatever you do, don't let them touch you above the neck.
Right.
Like above the shoulders.
No manipulation.
That's what I tell my patients as well. It's like I personally wouldn't let anyone touch my neck, or manipulate, the neck in any kind of violent way. Don't let a chiropractor do that. Lower back, it's like, it might, as long as they're not doing anything stupid, they could help your lower back pain. But it's not any better than just physical therapy or just doing anything really.
Yeah, it's
They
not
might
your
st-
brainstem.
Yeah, they might still hurt you, but they probably won't kill you. So,
Yeah.
at your own risk.
All right, Bob, you have an interesting entry, only the second entry into a possible new segment of the show. Why didn't I know this?
Oh, I have it as listed as how the hell did I not know that? All right, how are you saying it?
Why didn't I know this?
All right, okay, let me write that down. Gotcha. All right. Okay. So, this is fun. I recently experienced my own version of why didn't I know this? This has to do with what's considered to be the first laptop computer. Does anyone know this name? Is anyone even familiar with the first laptop computer? This is the Osborne 1 from the before times, way back in
way.
1981.
81?
Steve and I were using computers at that time, pet computers and stuff. I'm certain that we probably heard about this back in the day or saw an ad. I'm almost certain we probably saw an ad. But
Bob,
it's still
I saw
surprising.
this computer. I knew somebody who owned it.
No way. Who?
Yes. The father of my then girlfriend owned this computer. He was very proud
She's a
of
listener.
it. The guy loved it. This was like the best thing
Holy
that ever
crap.
happened to
He's
him.
still using it.
And I remember he showed it off to me. Went through the whole thing.
That's so cool.
The thing was a suitcase. I remember at the time saying this is not really a portable computer. It's certainly not a laptop computer. This is a luggable computer. That was the term.
Yes.
You could lug it around. But the thing is, like, he could take it to the work site and then take it home, and it's the same computer, and he loved that. And looking at it now, it's like, oh my God, It's
Yeah,
so
they
basic.
called it portable. My understanding is that it was called portable back in the day, and they were laughing about that term. Nowadays, it kind of morphed into the term luggable, and that's how we refer to these ridiculously heavy, portable computers back in the day. The story starts essentially though in April of '81 at the West Coast Computer Fair in San Francisco. Fair is spelled Faire. It seems.
Oh boy, like a
Which
rent
seems
fair.
appropriate. Right, exactly. First thing I thought of. The engineers and hobbyists that were there, they saw it as something that was very silly, and ostensibly they thought it was very unimpressive. So what they saw was something called a portable computer, but it tipped the scales at 24.5 pounds. 24.5. It was very rugged, though. It's essentially a hard shell of ABS plastic around it. So it could definitely, go the distance in terms of like lugging it around, which makes sense because that's what it was designed for. So imagine you've got this thing in front of you. So the first thing you would do is you would lower the front panel, and so it would click down on a hinge, and that would be the keyboard. So that front panel that flips down would be the keyboard. Okay, so above the keyboard and then facing you directly, right in the middle was this itty-bitty 5-inch monochrome CRT. And my question here is, does that initialism, CRT, does that require an explanation in 2025? Or has it
Cathode ray tube.
Yeah, has it slipped into obscurity like IRC and BBS probably had? I don't know, but
Maybe.
cathode ray tube, right? So the CRT was only a third of a standard terminal, showing only about 52 characters on each of the 24 available lines of text, right? But you can connect it. You could have connected it to a bigger display if you wanted. So that wasn't that much of a problem, but still ridiculously tiny. So then on the left and right of that screen is the two 5.25-inch, 5.25, right? The big ones, floppy drives. And
when
these
floppies were really floppy.
These were single-sided, single density, right? So they stored about 100 kilobytes each.
Yeah.
So that's just like, my God, like two or three modestly sized files, or maybe a small program. So yeah, not much capacity, especially thinking about the terabyte thumb drives today. It's just so ridiculously tiny. But in its time, you could get stuff done. And remember, though, that you might say, "Oh, wow, 2 drives." Yeah, that was critical because there was no hard drive. Remember that there's no hard drive, no USB drive, no Wi-Fi, none of that stuff. So you would have your operating system on one floppy. So you would boot from that, say, this floppy on the left, and then on the right you can actually load files or copy files to the floppy on the right. So that's why there were 2. Kind of critical. There was no battery on this first laptop. Battery schmattery. It only worked by being plugged in. Got to be plugged in or you're not doing anything. There were, however, games. They loaded text-based games that were very popular back in the day. One of them was Hammurabi, and the other one was called Colossal Cave Adventure. Text-based games. Wow. But none of this stuff that I've mentioned really got anyone's attention. It was more of a toy than a serious platform until several things were noticed. First off, it was the price. The Osborne 1 was $1,795 USD. That's about $6,000. That's $6,000 in 2025. So $6,000 sounds like a lot, but that was a hell of a deal back then.
Folks, also by comparison, there were new cars that were selling probably in the range of about $5,000 or $6,000 back then as well. So you would have to so this is the cost of like 1/4 of a car.
Right. So relatively speaking, that's a lot. But if you're a serious computer hobbyist or an engineer, or as we'll see in other professions, this was way worth it. And it gets even better when I discuss the second point here that was noticed. There was something brand new about this device, this computer, and it was a major part of its appeal. Preloaded, commercially useful software, what we would say a killer software bundle today. That was something that, as far as I can tell, was not done anywhere before this. Preloaded, commercially useful software. And the thing is, though, so it had, let me just list some of the programs that it had. It had, out of the box, it had CP/M, which is a 2.2, which is an operating system. It had WordStar, which is a very popular word processor of the day. There was SuperCalc, which was a spreadsheet. Then there was Mail Merge and both Microsoft Basic and C Basic programming languages. So this was all preloaded. The thing was, though, that this software was worth $1,500 USD. People were just astonished that was included. To them, it was amazing. So this computer was just about $1,800, and you were getting $1,500 worth of software. So it's like, the computer's only a small part of this deal. So it was an amazing deal when you factor in all that software that just came right with it. And the third revolutionary aspect of the Osborne 1 was, in fact, its portability and communication. That was something that was really dramatic for various professions. So even Osborne himself agreed that the performance of the Osborne 1 was really just adequate, but he would say that wasn't the point. The point was that this device was actually a ready-to-use office in a box. He claimed that it was the only computer that could fit under an airline seat. And these were essentially marketing points, but they were very, very effective. This device, once people digested this and realized what they could do with it, it was like crack to many professions. Like journalists were among the first groups of the first profession that jumped on board. They were almost immediate. Many of them got rid of their typewriter and exchanged it for an Osborne 1. For reporters, Osborne 1 was probably even more revolutionary. The newsroom became essentially wherever you were, wherever the reporter and their Osborne one was. That's basically your newsroom. You could be at a hotel room, you could be in an airport, you could be even on a battlefield. In 1982, reporter David Klein brought his Osborne one plus a heavy battery pack into the mountains of Afghanistan so we can cover the Soviet-Afghan conflict. You guys remember that? So writing and transmitting dispatches from the field was just you can imagine, it was just a total game changer. So I wanted to see, well, how did you actually transfer files, not at the battlefield, but say like if you were, in a hotel. That was the classic maneuver. You're a reporter and you want to file your story. How do they do it? There's no USB, there's no parallel ports, there's no wireless anything. How would this work? So one way to do it would be what's called SneakerNet. I don't know if you guys ever heard of SneakerNet.
Yeah.
That's just a goofy way of saying you would walk the file to where you needed to be and handing it over, like you would just hand over your floppy
on a
disk.
Yeah.
So, right. So that's one way. But the obvious, more popular option was to use Osborne One's serial port that lets you connect to either other computers or printers or, most importantly, a modem. That was the key right there. So if you were in a hotel room, you'd connect your serial port from the Osborne One into your separate modem device. Now, these were typically fairly big, these modems back in the day. These were acoustic coupler modems, and they were the ones that you literally just put your handset, the phone handset, right into it. You guys remember that scene in War Games? Yeah. That was a modem. That was an acoustic coupler modem. Then you'd run your terminal software that was already on your laptop, and then your office would get your story, and somebody there or the mainframe would be able to take it. And then you wouldn't need to dictate it. You wouldn't need to call anybody to dictate your story, right? That was a common way to do it. You wouldn't need to mail it. You wouldn't need to use a courier or whatever other method. So much easier and more convenient. So the sales for the Osborne computer, as you might imagine, this is the Osborne Computer Corporation. Sales were through the roof. It was just amazing analysts. And for a time, it was good. Amazing actually, until the Osborne effect. You may have heard of the Osborne effect. Oh boy. So the story goes like this. So they've had 1 or 2 years of amazing sales, selling so many thousands and thousands of units, making millions of dollars. And Osborne himself mentioned that the successors to the Osborne One, and then there was 2 of them, a stronger, beefier one and a smaller, even more portable one. But he mentioned them. And the problem was, as the story goes, he mentioned it a little bit too early, and it caused sales of Osborne One to dry up because people are like, why am I going to buy? Yeah. Right. Why? I'm just going to wait for the next one. So he kind of overproduced the Osborne One. They had a lot of those. And so sales dried up, income plummeted. And since their margins were apparently way too thin, they were just razor thin margins, and it led directly to bankruptcy. Just in 1983, just 2 years later, because of that snafu. So this scenario is called the Osborne effect. So, and announcing a new product too early has literally tanked companies before the Osborne One and afterwards. It's just this thing that happens that everyone's aware of, but it kind of has the name of the Osborne effect now. Now, the truth is obviously more complex than that. So still, the Osborne One was the first commercially successful product in this new category. It showed that there was a tremendous demand for a computer that you could relatively easily haul about. And some people say that there were other attempts at portable computers, but this is really the first portable laptop-esque type computer that was commercially successful product, and not just like maybe a one-off that barely did anything beyond that. It changed how computers were marketed, making them ready to work right out of the package. Software bundles were basically fairly ubiquitous, soon after that. Across the computer industry, tech companies worth their salt will always carefully plan product announcements to avoid Osborning themselves, if you will. And the Osborne One obviously foreshadowed the laptop as a juggernaut device for mobile computing decades before Wi-Fi and cloud computing. Kind of like I see it as like the Model T. It was a proof of concept for the masses that yes, this is a viable product. People will will shell out good money for this. It's got a niche. It's clearly got a place. I mean, I can imagine. If I'm go to speak at a conference, all of us, we're basically all bringing these laptops or tablets or even a phone. It's even a phone. You could do so much. So it was really an amazing introduction, and I'm just surprised that I wasn't more familiar with it. Steve, you actually saw one. Did you get a little demo? But you actually saw one. I've never actually seen one, but I'm sure I was familiar with it. But it just is just not in my memory banks at this point. I would think it would be something that I would at least be much more familiar with, and hopefully there's a bunch of you out there like, oh yeah, Osborne One, the first real commercially successful laptop that really showed what it could do. So interesting story. Check it out if you want more details.
Can't call it a laptop though, right?
It's not really. Yeah, it's not a laptop. It was.
Yeah, but it's
portable computer.
Portable. I mean, exactly. I mean, but it's not technically a laptop, but it's the portability, which is what makes a laptop a laptop. It's the portability.
All right. Thanks, Bob.
All right.
All right. So we have the report of the brightest fast radio burst observed to date. Fast radio bursts are FRBs. We've been talking about them intermittently on the show. They're, one of the current active astronomical mysteries. We don't really know what causes them. So it's a mystery that's unfolding in real time. What they are is what the name says, fast radio bursts. They're very brief, like 1 millisecond, 1,000th of a second, around there, burst of very high energy radio waves. So something very powerful clearly is causing them. Most of the ones that we observe are billions of light years away, which, you know what that means? They
occurred billions of years ago.
Yeah, so it's really two things. One is, if something is only happening very far away, that means it's only happening very far in the past. But it could also be that it's just rare, and you need a large volume of universe to observe in order to statistically see them happen, right? And it seems like it's really the second thing that's the case. It's just that they're relatively rare, and so we need to observe a large volume of space, which means on average we're going to be seeing them very far away. But
so it could happen very close, but it's very, very unlikely.
It's just
happen.
It's just unlikely. So the one that we're talking about now that was just observed was only 130 million light years away. No, that sounds really far.
Relatively
130 million,
close.
but that makes it one of the closer FRB. So it's the brightest, and it was fairly close. This is why we're talking about it, because those two things together, very bright, very close for an FRB, means we have really good observations of it. But there's
right. And Steve, you would think if it's the same mechanism, which we assume it is because we're calling it a FRB, I would think this would be a lot brighter since it's so much closer than, it's orders of magnitudes closer. So I would think it would be like ridiculously bright.
But I think they're talking absolute brightness, not just relative brightness. All right, so it's bright and close. That's great. We get a better look at it than other things. But also, as we've discovered FRBs, we've now started to develop the machinery specifically to look for them. So this one was seen by the CHIME. The astronomers love their acronyms. The Canadian Hydrogen Intensity Mapping Experiment. So this was originally developed to map the distribution of hydrogen in the universe, but it started picking up FRBs. And it's like, oh, cool. We're picking, this is some, we knew we've detected them in the past, but we've started to detect a lot of them with the CHIME. So it's between 2018 and today, it's detected about 4,000 FRBs, so several hundred per year. Now, the thing is, because they're so...
It's like one a day, man.
Because they're so brief, they're very hard to localize precisely.
And they don't repeat.
Well, most of them don't repeat.
Most don't repeat, yeah.
There are a subset, a minority of FRBs that do repeat.
There you go. Focus on those, babies.
And the repeaters can either be regular or irregular, meaning they could repeat, but at irregular intervals or
that just adds to the mystery.
But some of them repeat at regular intervals for a while, then stop, right? So, but most of them are one-offs. They don't repeat. Or maybe their repetition is so long, if it's 50 years, we haven't been observing long enough. So maybe that will change. Maybe it's really just a long interval. But anyway, they said, all right, CHIME is detecting all these FRBs, but we can't really localize them. We could localize them to their galaxy. We could say it's coming from that galaxy, even if it's 1 billion light years away. But we can't say where in the galaxy it's coming from. We need a bigger, we're going to need a bigger boat, right? We need a bigger telescope. And so what they built was what they call outriggers. Now, if you recall from radio astronomy, if you have 2 radio dishes 100 miles apart, it has not the sensitivity, but the resolution of one radio dish that's 100 miles in diameter. So that's why they built these outriggers, these smaller versions of CHIME, all across North America, which gives us a detection sensitivity as if we had a telescope as big as North America. So this allows for very precise localization of where the FRB is coming from. So now we have the perfect storm, right? We have these 3 elements together. We have CHIME with the outriggers, we have a bright FRB, and a relatively close FRB. And what this enabled them to do was to see precisely where in the host galaxy it was originating from. And it seems to be coming from the outskirts of a star-forming region. So star-forming region is where you have a collapsing cloud of gas that's churning out stars. Yeah, it's a nebula, but it's churning out stars, right? If you're in the middle of the star-forming region, you're probably a very young star, a newly minted star. The farther away from the middle you get, the older you are because you've drifted away, I guess, from the center of the star-forming region. So being at the edge means that it was it could have been millions of years old, kind of age, like it was an adolescent star, if you will. But also keep in mind that the bigger the star, the shorter its lifespan.
Sure.
So this could have been
couple hundred million years. They really don't last long.
Yeah. So
it's amazing. They have many times the amount of fuel that smaller stars have, but they go through it so fast.
Because they burn so hot. So
profligate.
So it's possible that this FRB was coming from a blue giant or whatever, a very large star that only in a few million years, so it was still close to its star-forming nursery, turned into a neutron star. The big stars are also the ones that become neutron stars or black holes if they're really big. But this is not a black hole, right? So the thinking is, well, at the very least, they're hoping that by identifying where in the galaxy these FRBs are coming from, they'll be able to ask questions and test hypotheses about what phenomena might be causing these FRBs. Now, there is kind of a leading theory.
Yep.
Bob, I know you know. Any of the guys have
a guess
of what the leading theory is as to what's calling at least the one-off FRBs, maybe if not the repeaters?
Yeah, no idea.
I really don't know.
So it's something powerful.
Black hole?
Supernova.
Of course,
a collision of super black holes.
Yeah, that's a really good guess. Bob guessed that, actually. That's a really good guess. It's something. If you have a really powerful event, it's probably related to either black holes or neutron stars, right? Those are likely candidates. Now, there's a specific kind of neutron star,
a flavor, if you will,
a flavor that puts out a lot of energy. It has a massive field, and it's cranking out X-rays and gamma rays, and that is a magnetar.
Magnetar. My favorite neutron star. They are amazing.
The reason
Don't get too close, Bob.
The reason that magnetars have something to do with FRBs, at least some of them, is because in 2020, and I can't remember if we talked about this. I think we did.
Maybe.
In 2020, we discovered the first FRB in our own galaxy. Which is unprecedented.
That's nuts, man.
And we were able to see that it was coming from a magnetar. So it doesn't get better than that. So many astronomers are like, until proven otherwise, magnetars are the source of FRBs, at least some of them, right? Again, maybe the one-offs, but not the repeaters or whatever. We don't know. But it's not all magnetars. It's something that's happening to a magnetar that's producing these rare
right.
FRBs.
It's some interaction, or could it be, Steve, could it be kind of like a starquake? A magnetar starquake, because a starquake is a it's rare, but it happens in a neutron star where part of the crust shifts, and because the matter is so dense, even if it's like a millimeter shift of a segment on the neutron star, it's so much energy is released that we could actually feel it from thousands of light years away. We actually experienced one of those not too many years ago. And it actually impacted our ionosphere and stuff like that. So it could maybe it's a magnetar starquake.
It's basically just unknown. So we had a solid piece of evidence that magnetars are the source of FRBs, but we don't know what's happening to make those magnetars produce the FRBs. Right now, we have only confirmed 40 magnetars. There's only 40 that we know of. So an FRB coming from a magnetar is probably not a coincidence, right? They're so rare that it wouldn't be like, it just happens to be in the neighborhood of a magnetar because they're all over the place. Nope, they're really rare. If it's in the neighborhood of a magnetar, that's probably the cause of the FRB itself.
And why are they rare?
Because they only last for a short period of time. They radiate away so much energy that the magnetic field, the super intense magnetic field, fades away over time.
Right, it calms down, which actually supports the story and the theory of why of them being rare, because magnetars just don't last that long.
Now, Kara, I know what you're thinking right now.
What am I thinking?
You're thinking, how powerful are magnetars' magnetic field?
I was thinking that.
Yeah, can you express it in Gauss?
I can express it in Earth magnetic fields. It's a trillion times as powerful as Earth's magnetic field. It's so powerful. How powerful is it? That if you were 1,000 kilometers away from a magnetar, you would instantly die because your molecules could not exist, right? It would disrupt the electron fields around your molecules. So your chemistry couldn't function, right? Within 1,000 kilometers.
Oh, yeah.
That's how intense the magnetic field is. Trillion times as powerful as Earth's magnetic field. But then they fade away over 10,000 years, 100,000 years, a million on the outside. So they don't last for very long, which means there's not many of them in the universe. So cool. So, just nice perfect storm. We got a nice little piece to the puzzle of what FRBs are. And but this story is not over. We really still don't know what is causing these really brief, really powerful events. I'm sure we'll be talking about this more in the future. All right, Jay, we're going to bring us back to Earth now. Tell us about turning trash into biochar.
Have you guys heard of biochar?
Oh, yeah.
Anybody else? All right, it was new to me as well, so don't feel bad because it isn't a common word that people come across. So let me just set the stage for you guys. Australia wastes about 31 million tons, which is about 34 million U.S. tons of food every year. So imagine, if you will, it's enough to fill roughly 20,800 Olympic-sized swimming pools, or you could build a food scrap mountain that's taller than Sydney Tower if piled up. Massive, massive amounts of food waste. And it's not just a number, it's more like you got to think of it like a landscape of rotting biomaterial that is ultimately...
Bob's haunt, gotcha.
It's not only a waste, but it's not good stuff for the environment. If you break it down, it's about 312 kilograms or 688 pounds per person every year. And that's 4 times the global average of 79 kilograms or about 174 pounds. It's just a staggering amount of what was described as largely like good food being dumped. Mm-hmm. So let me tell you what biochar is. I'll give you some details. It's basically a charcoal that's made by heating the organic material in a low oxygen environment, which is very similar to wood charcoal. This process is called pyrolysis, and it produces stable carbon-rich material. It could be added to soil to improve the soil's structure. It holds nutrients. It could support microbial life. It's a really interesting material. So there was a recent review that suggests the idea to turn food waste into biochar. And this review examines whether this could realistically work at a scale for Australia, which would be a very large. So they did find some legitimate potential here. So biochar can boost poor soils by improving their structure, their water retention. It can lock carbon in underground. They described it as, for decades or much, much longer. Australia's soils are, they're considered to be low in fertility, so this would actually help the soil. When you heat, for example, 10 kilograms or say about 22 U.S. pounds of dry food waste to around 300 degrees Celsius or about 572 degrees Fahrenheit, then if you do this for a short time, roughly 10 minutes, you can get back 7.6 kilograms or about 17 pounds of biochar. That's a yield of about 76%. And it's funny how these parameters, if you put it into the reactor for longer or at a hotter temperature, the yield drops, but it does create something else that could be useful as well. So there are these variables that they could use to make different properties emerge and things like that. On the energy side, the pyrolysis can be actually efficient. So, they're saying in a fast system, a system that is really hot in a short amount of time to treat the food waste, this usually makes less char at about 20%, but the energy to run them could be as little as 15% because they could reuse the gases that are emitted by the food waste as it's turning into biochar to fuel its own system, which, again, that's a really nice way to be efficient. So how do you measure biochar beyond the yield and weight? There is a list here I can give you. I don't want to go into great detail here because there is so much that I could be saying here, so I'll just give you kind of the headers. You could measure it by its carbon content and stability, how much carbon that's there that could be locked away, surface area, and how porous it is. This determines how well it will hold nutrients and water if it was buried in the ground. Its nutrient content, so does it have nitrogen, phosphorus, potassium, trace minerals, and that all depends on what the food waste actually is. Specifically, if it's a protein-based food waste or if it's more plant-based, the parameters change. They measure it by how much pH, what the pH is, and the salts that are there. Of course, too much sodium or ammonium can harm soil, so of course that would all have to be monitored and completely figured out. Its absorption capacity, which is very significant. How well will it soak up pollutants or metals? And its bulk density. This is weight per cubic meter. This is important for shipping cost. And, adding all of these things together with all of these different measures that I listed, they would be able to essentially figure out what the best case scenario would be for each one of these parameters. Or maybe they're all mixed, right? These parameters could all be mixed together to develop different types of biochar that are specific for certain needs. So, it's cool that there's so much flexibility here with what they could actually produce from just food waste. So, guys, why do you think they're proposing that we bury biochar?
Well, I think the big advantage, because I was looking into it as well, composting has a lot of the same advantages, and it's beneficial for microorganisms, which biochar does not have. But biochar has one huge advantage over composting, and that is long-term carbon sequestration.
Right. Yeah, that's a big one, especially today, of course, with global warming.
Yeah.
We have to lean heavy into that. There's lots of little things here to think about. So, first of all, it's porous. If they make it to be porous, which they can, water and nutrients are retained for crops, which is weird if you think about it. But the biochar that's buried would kind of be like batteries that hold water and nutrients that will leach out into the ground. Another thing it does is it stabilizes the carbon, like Steve was saying, for decades or even up to centuries. It will also prevent methane emissions that rotting food typically releases, right? So if you ever were near a dump, which I had the misfortune of being near a dump for a very short amount of time, and man, that methane smell that is put off by that material is absolutely horrible. But you can think of that methane is essentially energy. Beyond agriculture, the review mentions these other uses for it that are more experimental, but they were saying that it could serve as pollutant filters or lightweight concrete. So is this a good idea? Turning food waste into biochar is, it's a strong concept on paper. It is far from a guaranteed solution. that doesn't mean anything really negative. It just means, there's strong indications here that more research needs to be done. Where the researchers say that it's very strong is waste diversion, right? So it would take millions of tons of food out of landfills and cutting all those methane emissions, soil improvement, the carbon storage, and the energy side benefits. Like I said, the energy that would come out of the biochar as you're creating it could be used to make more biochar. It's weak with food waste problems. Like food waste is inconsistent. Like I said, it's wet. It's complicated processing. That adds a ton of complexity to the whole thing. The infrastructure costs would be huge. You know what I mean? This is industrial scale systems that, they don't really exist today in this form. All the information is there in different ways if you think about it. But to really, spike this thing out, it would have to be. So engineers would have to make a very finely tuned system that works specifically with all of these edge cases in order to pull it off. There are environmental risks. Some food waste biochars, will have salts and ammonium in them that can harm the soil and organisms. So that's another layer of testing and, post-production testing that would have to happen, which drives up costs. We really believe that it could work, but a lot more money and energy needs to be put into this. And if they were ever to even, build the first test facility, it would be a significant amount of money to build this out. That being said, I don't want to be too optimistic here, but this is the exact type of innovation that the world needs, in my opinion, because, food waste, even though it's happening the most in Australia, it's happening globally, and it is another puzzle piece to lowering greenhouse gas emissions and being able to gain control over sequestering carbon, which we really need to do.
Yeah, I think we have to say that the ideal solution is to reduce food waste, but that's easier said than done. There's a reason why there is like 30% or 40% or whatever it is food waste in this system. It's because food rots, and the system has losses all along the line, from the farm to the table, right? You don't eat every scrap of food you bring into your house. You just can't, there's no system could operate that efficiently. So we're always going to have food waste, even if we make huge efforts to decrease it. And I think the one thing we could say for sure is it shouldn't end up in the landfill. Mm-hmm. Right? Like composting and biochar, I think, are two good sort of end results for the food waste. Sometimes we feed it to animals too, like that's fine too. Animal feed is another reasonable way of recycling it back into the system. As long as it's not rotting in landfill and making methane gas, I think that's fine.
But Steve, there's a big question here that we didn't even address.
Yeah.
What the hell are people in Australia doing with all this food? What are they doing?
I don't know. I haven't read about that specifically. Why is their rate higher than the world average? Well, I'm sure the U.S. isn't great either, but I'd be interested to see, like, is there something systemic, or is it environmental? Is it just their, because they have to import a lot of food? I don't know.
Yeah, that could be it, Steve. Maybe it is because they don't have like a lot of land to grow food on, that they have to import it, and that could be it. I kind of was joking around, like, to myself, going,
it's probably some systemic issue.
Like they're doing all these outdoor barbecues. They're getting drunk and they're making too many hot dogs, and I don't know.
They don't eat hot dogs, Shay. That's
whatever. You know what I'm getting? I know shrimp. I don't want to say shrimp on the bar.
They don't eat shrimp either. They eat prawns and Vegemite.
Yep.
That's it. And that's
I don't want
Iran,
a
little roux, and occasional
Iran
roux.
to get pissed at me and be like, "What?"
I just don't want to read all the emails that are going to come after.
Yeah.
All right, Kara, tell us about declining reading rates.
Oh, you said that so joyfully.
Does that mean people are reading more slowly these days?
No.
Okay.
Unfortunately, it does not. Okay, so there was a study that was recently published in an open access journal called iScience. These are researchers from London and Florida who wanted to understand a little bit more about trends in the U.S., specifically with regards to how people are reading for pleasure. And so they asked several questions. It's an interesting study because they were able to use self-report data, but self-report data, survey self-report data from a really large representative sample. So the kind of larger database is called the American Time Use Survey. And basically from 2003 until 2023, over 10,000 people every year provided nationally representative estimates for their average day across 20 years. So basically they said, this is what I did in this hour. This is what I did in this hour. And so what we're looking at, and I think this is important to understand because I didn't quite get this when I was reading some of the coverage of it. You're looking at a day, just like a blip, like in an average day, this is the percentage of people that read for pleasure. You're not looking at, these are the percentages of the people who read what they were, when they read. Does that make sense? So we're looking at sort of a cross-section of time, 10,000 people, representative sample, meaning it represents the U.S. in terms of age and marital status and race and income level and education. 10,000 people, hopefully representing, the trends of the whole country. And they wanted to know a bunch of different things, Are people reading on an average day? How much are they reading? Where are they reading? Who are they reading with? And yeah, they collected all of that data, and then some interesting findings came out. So if I were to ask you on an average day in that survey in 2023, which is the most recent year that they have whole data for, how many people, what percentage of the people in that survey read for pleasure on an average day?
Wow.
Gee, I don't know.
50%?
50% read for pleasure? What do you think, Evan?
Define pleasure?
I can define pleasure. They called that either, so they actually called it reading for personal interest, either reading a book, magazine, newspaper, or listening to an audiobook, or reading on a Kindle or e-reader, or reading a library book.
Oh gosh, I think it's higher than that. It's probably 65%.
I'd say 70%.
Does that include reading the news?
Yes, newspaper.
Book, magazine, newspaper, yeah.
Yeah, I think it'd be fairly high.
16%.
What?
That how are we so off on that?
16%.
Really?
Wow, that's crazy.
Read for pleasure.
Any of those things.
Any of those things. For pleasure,
Wow,
for pleasure.
That's a shock to the system.
Yep.
I read every day.
Them,
I read every day.
Yeah.
There's not.
Yeah, because we are not the average American. And that's something that's really important to understand. So they found that over the course of this 20-year study, decrease in reading engagement declined 3% every year. Every year, 3% fewer, 3%
oh my
fewer,
gosh,
3%
and they have
fewer.
some theories as to why.
Mm-hmm. So they are, the researchers are very worried, I should say. They did say that the numbers are not kind of even across all demographic groups. Definitely people with higher education and women are more likely to read. White people are also more likely to read, but they are seeing shifts even among those. Now, here's something that's interesting. Of the people who read, the time spent reading has actually increased slightly, but most people don't read. And when you average out and this is what I'm still trying to understand, I got to dig a little deeper into how things are worded in here. But the researchers are saying that in 2023, participants spent an average of 16 minutes reading for pleasure on a day, but only 16% of participants read for pleasure. So I still can't figure out if that 16 minutes is averaging all the other people who had 0 minutes. Does that make sense?
Wouldn't it?
Yeah, I get it.
I think it is, because they said of the participants, the 16% of participants, the average person spent an hour and 37 minutes reading. Mm-hmm. So basically, the people who read are really reading. Like, I read a book every night before I go to sleep. I also read news articles during the day. How do you guys generally engage with your reading?
I generally read throughout the day, mostly articles.
Okay.
But
Mostly
I do
articles for me.
Some like just novel reading in bed at nighttime, usually.
I do
so you would say probably
every
like
day, just
5 to 15 minutes, but in like little pockets throughout the day?
Yeah.
Okay.
Yeah, I listen to audiobooks whenever I'm driving. So, and then the reading though is I don't consider reading the news pleasure reading in the last half year. It's a drudgery that I have to do that then I can't do anymore, and then I'll go to like reading about physics and astronomy and stuff like that, just to cheer up and be in my happy place.
And truth be told, it still probably would be considered reading for pleasure because nobody's making you read it.
Right,
You're not doing it for work.
Yeah. I know, but it's not pleasurable.
Yeah, so I would say I probably read like a couple articles a day, depending on the day, depending on what piques my interest. And then at night, I probably average anywhere from 30 minutes to 2 hours reading, like in bed before I go to sleep, just depending on how early I go to bed.
And
that's
do you use a Kindle or electronic device?
I use books.
Oh,
I
yeah,
read, like,
good
paper
old
books.
books.
Yeah, with a little
those.
nightlight thingy, a book lamp.
Yeah, I'm like, I read a lot of stuff for work and news during the day, and then at night it's all pleasure reading.
I mentioned that these declines at 3% each year over the course of the 20-year study was not equivalent across demographic groups. Black Americans with the lowest education, the lowest income levels, and living in outside of cities, so in non-metropolitan areas, showed the steepest decline in reading. But even across that, we're seeing that, women and those with higher education were more likely to read and were more likely to read more. And so the question is, what is causing this? And I've been curious about this too, because I'm not sure if you guys remember kind of a bevy of stories popping up last year, beginning of this year, in a lot of long form magazines like The Atlantic, Forbes wrote about it. Kind of these op-eds from college professors being like, I don't know what to do. My students don't read. Like, I'm getting these crops of students out of high school who say that they've never read a whole book.
Oh my God.
Have you guys read any of these articles?
Yeah.
There's one in a Forbes called Kids Can't Read Books. There's one in The Atlantic called The Elite College Students Who Can't Read Books. And so these are, again, op-ed pieces that are written often by college professors or even some high school students saying, like, things feel different now. And I don't know if this is, old man, shaking fist at cloud, if every single generation says kids today, or if there's real data behind this, because there isn't a lot of good survey data about how often kids read. But we do see anecdotal evidence that shows, college professors saying that students are coming up to them being like, I'm having a hard time keeping up with your assignments. And when they say, okay, well, how long did it take you to read a book in like your English class in high school? They'll be like, oh, we never read a whole book. We would just read like excerpts.
Oh my gosh.
Yeah. Or like they would assign like a chapter.
Oh God. I used to take classes where you read a book a week for the whole semester.
Yeah. So in one of these articles, that is what they said, that they, historically would assign, 14 books in a semester, and now it's down to like 6 or 7 because that's all the students can handle. So, but there are a lot of factors here. What does that mean? Because a lot of these professors and scholars who are writing about this are like, kids can still read, just don't. So like,
sure about that?
What's going on here?
As long as it's not in cursive, they can.
Right.
Attention span.
Okay,
man.
so like, could we chalk it all up to attention span? Do you think that has...
Partly.
Yeah, I think that's some of the variance for sure.
There's a lot of diversions.
We do have a lot of diversions, right?
Lots.
A lot of people blame social media.
Easy diversions.
Distractions.
Yeah, they're like, how are you going to read if you can just look at TikTok and you can get some new kind of dopamine hit every 2 seconds? But also, like, there's a survey of seniors in 2023 that said that they spent... A self-report survey said they were spending just as much time on jobs and extracurriculars as they were on academics. Also, there's been a lot of grade inflation. For example, in a recent report, 79% of grades at Harvard were in the A range. Like, do you really think 79% of students at Harvard are making A's? Probably not. It should be a normal distribution, right? Clearly a lot of college students are, getting by without doing all of their work. Some of these different experts are blaming things like Common Core. They're blaming shifts to national academic standards that have moved away from the more sort of nuanced skills that are gained from reading a book in full and really engaging with the text, more towards standardized testing and, hitting certain benchmarks. Okay, what was the, the thesis statement? What were, 3 points that you can make from this? Some of those things that you can do without having read the whole book. There's a EdWeek Research Center survey that I came across of 300 3rd to 8th grade educators. Only 17% of them said that they primarily teach whole texts. About 49% said that they combine it with anthologies and excerpts. A lot of teachers are saying that they might, assign a part of, let's say, Homer's Odyssey. They talk about this in the Atlantic article. They would assign a part of Homer's Odyssey, and then they would supplement it with music and articles and TED Talks and different things that aren't just books. But it does seem to be the case that fewer students are reading books in school, and I don't know if that's what's translating then to fewer adults reading. One other part of this study that I didn't mention is that they did look at the percentage of individuals in the survey who read to children. Let's play guess, because this is rough. On average, the average across all participants in 2023, remember this is 10,000 representative sample, how many minutes on average did participants spend reading with children every day?
Half an hour.
30 minutes on average, these 10,000 participants?
That's my guess.
What do you guys think?
That's probably something like that.
29 minutes.
1 minute.
Yeah, 30.
1 minute.
One?
But that's probably, again, because
for 1 minute.
Only 2%. That's the average across all of the participants. So that's because only 2% of participants in the survey read with children.
Or the median. What's the median?
200.
That's what we really want.
So again, only 2% of the 10,000 read with children. And so of those 200 participants, so if we just look at the 200 who did read with children, they spent an average of 28 minutes, doing so. So that's pretty sad, because even those who did read with their children were only reading half an hour a day with their children.
That's bad.
It's really bad. Yeah, and so they also looked at things
that's negligence.
They looked at things like, are people reading at home? Are they reading outside of the home? Blah, blah, blah. But I think those are some of the really, really big takeaways, is that just people aren't reading anymore. And this is really disconcerting for, a lot of educators and academic researchers, psychologists, sociologists across the board, because we know that reading, and especially reading for pleasure, is associated with all sorts of really important skills. So not just direct gains like comprehension skills, vocabulary, logical reasoning, recall, but also things like empathy. It's very hard to cultivate empathy if you can't read a story and see the world through the lens of the characters in the story. And going from the beginning to the middle of the end is also really important. Things like, emotional intelligence, I'm putting that in quotes, but however you want to define that. We're not just talking about academic achievement or gainful employment or career growth, but also, stress reduction, improved sleep, slowing cognitive decline as we get older, literally reducing anxiety and depressive symptoms. There is so much literature to show that reading is highly correlated with so many important sort of cognitive, emotional, and just functional skills. And it's low barrier to entry. It's inexpensive. And we should be increasing access, but not just access, because clearly this probably isn't just an access problem, but excitement and interest in reading as well. So, of course, the researchers of this study, they didn't research what's causing it, but they point to a lot of different things, right? As we mentioned before, people are distracted, people are on their phones, but that can't be the whole answer. The way that we educate our children has changed over the last 20 years, and that might be affecting them. But also, why do we think that people in low-income neighborhoods are reading less? Because it's probably a luxury. They literally can't afford the time to read.
They don't have books in the house.
They don't have books in the house right there. They're probably not going to the library. And also, when you're working multiple jobs and you literally don't have free time just to make ends meet, you're not going to be reading with your children.
Right. Hard to foster that environment.
So these are systemic sociocultural issues as well that we have to address. Reading, in some respects, is sort of a luxury, or it has become a luxury, but it's so fundamental to, I think, a healthy functioning society and just to humanity. And it's, I think when I came across this study and the write-ups of this study, it was very, very alarming for me.
Yeah, it is a little bit alarming. I do think, because when you read, I know you can consume information in video and audio format. Reading isn't the only way to get information, but you definitely engage with the material differently.
Absolutely.
When you read. I think, you get it much more of a deep, I think, understanding. It definitely is more amenable to like doing a deep dive on a topic and really wrapping your head around it, rather than just here's a quick narrative, go on to the next thing.
And we know that to be true, because we have plenty of evidence that shows that people who read more have higher comprehension skills, right? People who read more can engage with the text in a deeper way. They can see metaphor in the text. They can then take whatever they learn from the text and apply it to other situations. And yes, as strange as it may seem, there is a lot of literature showing that reading is directly correlated with improved psychological well-being and increased empathy for others.
Wow, that's a good point.
You gotta be able to read stories and think through the lens of the characters in the stories. Yeah.
Yeah.
Such a bummer.
I agree.
Yeah.
All right, thanks, Kara. Evan, is this good news? Are most Americans skeptical of the paranormal?
It sounds like it's good news, right?
Mm-hmm.
But maybe we need to define a few things here.
Okay.
In this particular poll, yes, I'm talking about a recently released Gallup poll titled Paranormal Phenomena Met with Skepticism in the United States. 2/3 of Americans are skeptical of paranormal beliefs, and none of the 8 concepts in this particular poll are believed by a majority of people. Okay. On the surface, that sounds very good, very positive. But we have to delve a little bit deeper into it, as always. Here's a little background. It was a nationwide poll conducted from May 1st to May 18th, 2025. Gallup surveyed 1,003 adults about 8 paranormal phenomena, and I'm going to go over the 8 with you. We have talked quite a bit over the years about polls. They are imperfect, and some are more imperfect than others, and they are not to be mistaken as scientific evidence of anything. They're informative, okay, in a very general sense. You can measure the moods and sort of attitudes of certain groups of people at any given point in time, but maybe the best purpose they serve is to compare trends. In other words, how did people respond to the same poll back in 2001? As compared to now in 2025. I think there's something there worth looking at. But it's not science, okay? You always have to take polls with various grains of salt. But let me start with this. It's the 2025, this recent poll. And I'm going to ask you, my fellow rogues, to guess at some of the percentages here, and let's see what
4.
you think. Here is how the question was phrased. And these were people who were called by the pollsters. So these respondents were willing to answer their phone. You have to kind of keep that in mind, for however that skews who these 1,003 people are. Kara, there's no way you would have picked up your phone for this. For each of the following items I'm going to read to you, please tell me whether it is something you believe in, something you're not sure about, or something you don't believe in. All right, here's what I'd like to do with you. I am going to tell you the 8 paranormal subjects, and I'd like for you to throw out some guesses as to how many you think believe as a percentage, as a believe. Just give me the believe. I'll deal with the don't believe. But for example, one of the categories is witches or witchcraft. What percentage do you think believe? This is U.S. people.
40.
40?
30.
We have a 40.
Quarter.
Steve's closest. 24%. 24%. That seems high.
1 in 4 people believe in effing witches.
Let's try reincarnation. The rebirth of a soul in a new body after death.
So witches was 24. Reincarnation is probably higher. 30.
Okay. Anyone else?
40.
42.
It is also 24, same as witches. Right. Let me jump to another one here for you. Psychic or spiritual healing, or the power of the human mind to heal the body.
That must be much higher.
24.
Or the power of the human mind to heal. God, so many people.
Yeah, I would think
60?
that one's higher.
Yeah, I'd be up in
not that
well,
high,
you said
but it
none
was
of them
the
had a majority,
sorry,
right?
okay.
So it's got to
yes,
be
that's right.
Probably
So,
high
right.
40s.
Yeah, high 40s. This is the highest of them, and it was 48%.
48.
48%.
48.
I'll go down the rest for you. Ghosts Spirits of dead people that come back in certain places and situations, 39%. So, yeah, 39%.
Surprise.
Telepathy or communication between minds without using the traditional 5 senses, 29%. People can hear from or communicate mentally with someone who has died, 27%. There's clairvoyance, the power of the mind to know the past and predict the future, 26%. And finally, astrology, 25%.
That's still freaking high.
Yes, it's very, very high. It's way too high, if you ask me. So
it's basically all between a quarter and a half, basically, for these various things. It's
Now, Gallup, and so I'm going to get to my point that I brought up in the beginning. Gallup used what they call a cluster analysis to group this same group of 1,003 participants by how broadly they believe in the paranormal. Here's what they did. And I have reservations about this, but this is what they did. They took the 1,003 respondents and they categorized them into 2 camps. Those who were open to belief and those who are skeptics. So where's the division? How do you divide them? If a respondent answered in the affirmative to 3 or more of those 8 categories, they were in the open to belief group. If they answered in the affirmative in 2 or less, then they are in the skeptics group. That's how they divided it up. Now, I know how I would have divided it up. It would have been 0 as skeptics and 1 or more in the open to belief group, but this is how Gallup did it. So when you have those 2 camps, the 2 or less or the 3 or more, 2/3 wound up 2 or less, and the average was 1. So 66% of these 1,003 people, they classify this way as skeptics, and 1/3 of them were open to belief, and the average score there was 5. They averaged believing in 5 of those things.
Yeah. But of course, to us, if you believe 2 of those things, you're not a freaking skeptic.
Correct. Yeah. Right.
So I don't mean by but we mean by the relatively speaking, they were skeptic.
And I mentioned comparing to prior. They said here, and I'll quote, interestingly, these results haven't shifted much compared to Gallup data from 2001, for example, so 24 years ago. Belief in most of these phenomena remains stable, but there are slight declines in belief in psychic healing and clairvoyance. Those had a 6-point drop, and there was a 7-point decrease in telepathy. But all the other 5 categories remained about the same, within a point. So when you read a headline from a polling place, and Gallup does good polling on a lot of things, but the reminder here is take these polls with grains of salt, people, please. When you read the headline, paranormal phenomena met with skepticism in the U.S., yes, in a certain sense, but I think in reality, no. I don't think that there is much. I didn't get how many of these respondents said 0. I think it was 10%. No, 10% believe one of them, but they didn't give me a number for how many believed in 0. So it must have been less than 10%.
Oh, that's crazy.
Mm-hmm. And that's alarming to me. Mm-hmm. That's 90% or more believe in at least one of those things, which are obviously
but I think that sometimes my gripe with Gallup is how they word questions. And I feel like including in that the power of the mind to heal, you're going to get a bunch of people who aren't necessarily pseudoscientific. They're just more like... Yeah, exactly. They're going to read that.
Sure.
It's not necessarily paranormal.
Yeah.
Right.
Whereas ghosts are 100% off.
And that's why I think those cutoffs are interesting. I mean, maybe their cutoff should have been 1, not 2. Sometimes when you do cluster analysis, you actually look at natural breaks in the data. Yeah. Mm-hmm. And they may have seen that people clustered around 3+ and people clustered around 2-, and they were able to say these look like 2 distinct groups.
And witches could be Wiccans.
Yeah. They could be people who identify, who are like, I am a witch. This is my religion.
Or I don't know if, Satan specifically wasn't brought up there, but I don't know if somebody would consider that part of witchery. Yeah. I don't know. All right. But maybe.
All right. So basically things haven't changed.
Cool.
You're right. So wait a minute. I thought we were making a difference. Damn it.
Well, it would be worse if it weren't for us, Evan.
You said there were fewer people who believe in clairvoyance. That's good.
There are, yes, a couple of these trends did go down by 6 to 7 points. 3 of them.
All right, Bob.
Yes, sir.
You're going to tell us about a quantum alternative to GPS, but I thought that GPS was quantum.
But not in the way that you think.
Okay.
Well, let's see. See if you have any questions. So you guys remember X-37B? That's the uncrewed U.S. Space Force space plane.
Yeah, nobody's supposed to talk about it.
It's done many mysterious classified missions around the Earth. And if previous trends continue, I suspect that the X-37B will be renamed something like Super Ultra Space Jet, much better than Elon's, believe me. So, but we shall see. We shall see what happens. Probably far worse than that. The space plane was recently launched, and one mission it has that we know about is testing a new quantum inertial sensing system. This is an alternative to GPS, and it's the first time such a system has been deployed in space. Now, inertial navigation describes essentially an internal system that can track your changing location without using external references such as GPS, right? It's pretty much all inward looking and calculating and not outward. So GPS is great. I don't know what the hell we did before. I do know what we did before that, and it was annoying, and I never want to do it again. So I love GPS, but it doesn't work everywhere. Places that will never probably be, like deep space is one, and underwater as well. But also there's certain environments that are described as GPS denied, but they include some obvious ones: underground tunnels, right? Dense forests. And what was the other one? Urban canyons with tall buildings. So those can also be GPS denied. So not only does GPS not work everywhere, there's also ways to compromise it, to spoof it, to jam it, or just disable just conventional GPS signals. So being able to navigate without relying on these external GPS navigation signals, it can be critical in various scenarios, as you might imagine, such as conflicts, battles. You could see how, we need to get away, or we need a way to rely on something that just can't be messed with. That's better than GPS in various scenarios. So now we do have conventional inertial navigation. And I talked about one system that was pretty slick. That was many years ago. I couldn't find the episode. But so this is conventional inertial navigation, and it relies on things like gyroscopes and accelerometers to accurately track on board how fast you're going and in which direction, right? So if you start in a known location and it's tracking you with the accelerometer and gyroscopes, where you're going and how fast, it could then just build up and calculate exactly, where you are in relation to like a map that it has on board. But these suffer from things like error drift, where you become increasingly farther away from where you think you are, right? So that just builds up over time. Now, this new quantum system offers orders of magnitude better accuracy and stability thanks to atom interferometry. So this takes advantage of the wave nature of atoms. Look it up if you're not too familiar with it. It's fascinating. It's like the magic of one of the magical things of the universe that is just so fascinating and counterintuitive and weird. So in this scenario, atoms are cooled down to millionths of a degree above absolute zero so that their wave properties can be manipulated with very high precision. Okay. So a laser pulse then is able to put each atom into a superposition of two paths at the same time. There's many ways you can look at this or describe this scenario. Another way to describe this is to say that the laser splits the wave function of the atom, so one part goes down one path and the other part of the wave function goes down the other path. So that's another way. So it's pretty complicated. So as you might imagine, when these split paths recombine, an interference pattern is created, and that actually this interference pattern contains exquisitely detailed information about how they had moved. Any small acceleration or rotation taken by these atoms will shift the relative phase of these two matter waves. So this is the quantum equivalent of bulky physical accelerometers and gyroscopes that are used in conventional inertial navigation. Otherwise, it's very similar, tracking your movement and speed, direction, all that. So the results with quantum inertial sensing, though, have a threefold advantage to the non-quantum version. One is stability. Stability is much greater with the quantum system because they don't have the material imperfections that are inherent with any mechanical, any bulk mechanical or optical gyroscope. They have these material imperfections that are going to impact the results one way or the other. So another advantage to this system is accuracy. It's much greater because any errors will grow much more slowly using this quantum system. So, for example, the old non-quantum inertial navigation or sensing system could wander off course by miles in a single day. These quantum versions, however, could potentially stay locked within a few meters for days or even weeks. So that's just tremendous. I mean, comparing many miles in the course of a single day being off to a few meters in error that stays consistent, for like days or even weeks. Incredible increase in accuracy. The final important advantage here is resilience, right? We kind of covered this. The resilience is much higher for this quantum inertial sensing because they can't be jammed, they can't be spoofed, or suffer from any type of signal loss that would plague systems that rely on GPS, because this is all internal. So, okay, in a sense, this new system is kind of like LIGO for atoms, you could say. So instead of light waves interacting with each other, we have matter waves interfering, creating an amazingly sensitive motion detector. And I can't help but thinking, what other uses we could make out of this type of technology. So stay tuned.
So this is not, being deployed yet. This is still in the experimental stage.
This is tested on the this super ultra space jet. It's being tested on that mission. And so, probably won't, I don't know how much we're going to hear. We know about it now so it's not too classified.
Yeah.
But so maybe we'll hear some if it was successful or not. So interesting stuff. I remember covering the inertial guidance system years ago, and it was fairly sensitive, but this just looks far, far superior.
All right. Thanks, Bob. Jay, it's Who's That Noisy time.
All right, guys. Last week I played this noisy. Seemingly going on forever.
Yeah.
You guys
as long as Will Robinson's okay, I think we're in good shape here.
Yeah. Well, okay, so let's get right into this. So Michael Blaney wrote in, "Hey Jay, it's got to be a bird of some kind." So right out of the gate, I'll say, yeah. I mean, there's a lot of evidence there that it's a bird. He said, "I noticed Steve stayed quiet for it, so I'm going to guess it's the showbill. They make some weird ass noises, Michael." My response to that is I would imagine that a lot of birds make the noise I just played, but I think this is a common sound that this bird makes. So you are not correct with the bird that I selected. But, if you could play me an audio of that type of bird making that noise, I'll still give you one SGU point. A listener named Montgomery wrote in and said, "Hi, Jay, this sounds like the Pengu from the popular kids show of the same name."
No way.
Pengu. Absolutely love the work you all do and hope semi-retirement treats Steve well. Have any of you guys seen the Pengu show?
Yes.
Does it make that noise?
No.
Let's move on. A listener named Craig Messerman said, "Jay, this week's Who's That Noisy sounds like the alarm on the self-driving floor cleaner at my local Winco when it runs over an old lady." Oh my God, I didn't actually read that last part. Wow. Then he says, not the last part. Okay, so the floor
newly
cleaner,
cleaned old lady,
exactly.
The alarm that the self-driving floor cleaner makes at the local Winco. So there is a robot at my local Stop and Shop.
Yeah, I've seen them as well.
And, the thing, like, they put googly eyes on it as if that's enough. And I'm just like, no, this thing should be making noises. It should be like an R2-D2 type
Whistling
of thing.
Whistling a tune or something, right?
Yeah, anything. That'd be kind of fun. It's like whistles a little bit.
I could beat that. I've got in my local Big Y, I bring Mom there quite often. They have a kind of like a robotic floor cleaner. And as of last week, there's somebody clearly at this Big Y that is awesome because they put a skeleton riding it, and it was, I love it.
That is fantastic. That's the kind of creativity we need in this world.
Yes.
Evil Eye wrote in again, and Evil Eye said, "I want to say a white bellbird, but Steve will know that's wrong, but that's my guess." Apparently, Steve, they think that you are a bird whisperer and you know it all.
Oh, yeah.
Apparently.
All right, so I was not sure that someone was going to guess correctly, and nobody did guess correctly. That's 2 weeks in a row, which means I need to loosen the belt a little bit, and I will try to pick something a little bit more identifiable. So what this is first off, this was sent in by a listener, an 8-year-old listener named Victoria. one of Victoria's parents sent it in. She recorded it herself, and she made sure that they remembered what it was exactly, including a photo. So thank you very much. Wonderful Noisy. Good job sending that in, Victoria. And if you hear any other cool stuff, send that to me again, please. So nobody won because it's a little hard. So what is it, guys? You have any idea?
Where's Victoria from?
I will tell you. She's from Australia.
Oh, Victoria.
Cassowary.
The person who sent it in said, good luck saying my name. And the parent's name is Gabor Fagarashi.
Probably Gabor.
Ghabor. So if I was correct or incorrect, email me and let me know. I have no shame at all in mispronouncing things. It's just part of who I am. This is called a glossy black cockatoo. They are very cockatoo-ish, but they're glossy and black, and that's why they named it that.
Oh, they're beautiful.
Yeah, many birds make that kind of repeating tone.
With those
that's the kind of noise that you would think like the animal kingdom would just kill whatever animal's doing it. You know what I mean?
Right. Smack it like an alarm clock. You know?
There's just nothing pleasant about that.
That much selective pressure.
Look at those red tail feathers.
It's a cool bird. I have a new Noisy though. But before I play the new Noisy, I'd like to play you something else. And this was sent in by a listener named Dustin Edwards.
Wrote a song about it, like to hear it,
babble,
here to go.
babble, banana, babble, babble, babble. Banana, blah, 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 banana, banana, me.
That's me.
Steve said all those things.
Wow. Well, clearly.
I was talking about communicating with animals, right?
I don't quite remember. But the thing is that this person mashed you up, Steve, and it's very funny.
Yeah.
I love that type of thing.
We need more mashes.
Remember, somebody was doing that for a little while. They were sending in mashups of us saying all sorts of different
great.
stuff.
Yeah,
they're always
fun.
funny. It's really
Fun.
like a comedy-prone thing to do. I think it's very
We should have a
hard not to.
contest.
All right, so this particular Noisy I'm about to play you was sent in by Daniel Berliner. I believe that a lot of you will recognize something in this Noisy, but I need you to give me the answer in a very specific way. Okay, that is this week's Noisy. Be specific. You can send me your answers to WTN@theskepticsguide.org. We are currently in full swing producing our new political podcast called Political Reality. It is going really well. We had we did a test recording, and I'm bringing in all the assets now, like all the creative stuff that needs to be put in place in order to begin building it out. I have a very strong feeling that this is going to be a
lot of work.
Well-loved podcast. I hope it is, of course.
Yeah.
But if you want to help the SGU do projects like this and also other projects that we have in the queue that will be coming at some point down the road, and if you support the work that we do, then please consider becoming a patron of ours. You can go to patreon.com/Skeptics Guide. This is a good time to do it because we have a lot of stuff queued up, and our bandwidth is partially dictated by the cash flow that we have. So please consider that. You could join our mailing list. I've told you guys many times what it is.
Join us.
If you're interested, go to theskepticsguide.org, and there's a link on there for you to sign up. We're going to Kansas, guys. September 20th, we'll be doing 2 different SGU shows. One of them will be a live podcast recording, and the other one will be our stage show with George Hrobb. That is called The Skeptical Extravaganza of Special Significance. It's a lot of fun. If you haven't seen us do it, I highly suggest you come out and check it out. We've been refining that show for a long time, and we have a great time doing it, and the audience always is enjoying it. So please join us on that.
All right. Thanks, Jay. One really quick from TikTok. We talked about a lot of nonsense today on TikTok, but there was one we didn't get to. In this video, the woman is claiming that finally Switzerland bans mammograms, right? Because mammograms are horrible and they cause breast cancer.
What?
That was basically the
I
essence
have a
of that
mammogram
TikTok
tomorrow.
video.
Why didn't anyone tell me?
So you should keep your appointment for your
All right.
mammogram. So that's an urban legend. That's a myth that's been going around for years. Now, there was a committee who made recommendations to scale back the screening for mammograms. So this is not mammograms themselves, but should we routinely screen people with mammograms versus individual women needing to be referred by their physician to get a mammogram? And the committee recommended scaling back the automatic screening, but not because of the risks of mammograms, not because of what this person was saying, but because of, and we had this debate in the United States around the same time as well, because of the risk of false positives. Because if you get a false positive, it causes a lot of stress. It leads to further testing. It may lead to unnecessary procedures. And if you routinely screen a low-risk population, you get more false positives than true positives. And so it's all a risk versus benefit calculation. That's what was going on. But that got misconstrued by losers on the internet as they banned mammograms in Switzerland. Interestingly, the government didn't even accept the recommendation. They didn't make the changes they recommended. They kept them because there was an outrage by, the experts who were like saying, this is not what's best for women. The risk versus benefit favors routine screening at a certain age or at a certain risk. And basically came to the same conclusion in most other countries as well, that yes, we have to consider the risks of false positives, but all things considered, once you get to a certain age, the benefits of mammograms outweigh the risks. Mammograms are actually extremely safe. They may be uncomfortable, but they use very, very low amounts of radiation, and they're very important for early detection of breast cancer. They have a massive positive benefit on the outcomes because of early detection, and the benefits are definitely worth the tiny risk of the small amount of radiation you get. So this person was talking out their ass, basically. They had no idea what they were talking about. They were just relaying an urban legend and then thinking they're smarter than all the world's physicians. Just there's this subculture on TikTok that just thinks all doctors are evil. Yeah. It's childish. It's really childish. It's tinfoil hat conspiracy level nonsense. But they get a lot of playtime, unfortunately. It's just really crazy.
Steve, can I ask you a question about mammography that you may not know the answer to?
Sure.
So are ultrasounds just as safe?
So they are, their ultrasounds are extremely safe. I don't think they're as sensitive. I don't think they're as good in terms of their ability to detect subtle early breast cancer. But
interesting. Because ultrasounds are where they send you after they see something on mammogram.
Well, if they see a cyst, then they want to know. Ultrasound gives them more information, so it's not really used for screening.
For the baseline.
So, like she was saying, do that instead. Or somebody in the comments was saying that's not an instead thing. It doesn't serve the same purpose. That's how you explore
once you already
a known lesion to see. What is the composition of that?
I had an ultrasound.
Yeah.
I think that's why I was asking, because when I had my the baseline mammogram, at least as was explained to me both by my physician and the mammographer, was they need to make sure that it's like the best imaging they have, because it's going to be what they compare everything to in the future. And so it's not uncommon to have to go back and get a second imaging done. In my case, I have dense breast tissue, so I had one little spot where if they squeezed it just the right way, it would disappear. And so what it turns out to be is just dense tissue on top of dense tissue, and that lit up on the mammogram. Yeah. So they re-mammogrammed me. They figured that out. I got an ultrasound. They said, okay, it's not there. Good, you're good. But still in 6 months, let's do another mammogram just to make sure. And I was like, in my mind, of course, after all the smashing of the boobs, I was like, can't we just get an ultrasound? It's so much less painful.
So the ultrasound they're just not, they're complementary.
Right.
It doesn't replace it. That's for looking at that shadow, is that cystic, or what's the density of it, versus looking at everything to see is there any trouble.
Whereas the mammogram gives you the whole breast from multiple angles, and they can
exactly.
Okay, that makes sense.
And how often is the recommended chest?
Depends on your age.
I don't know, but we start at 40.
And family risk. 40. That was the controversy. Was it 40? Is it 45? Is it 50? There's no right or wrong.
No, there's not. But we know that
zone.
I see, I work in a cancer center. I see patients all the time who get breast cancer at 35, at 30, at 28. It happens.
Gosh.
So
absolutely. Yeah. All right, guys, let's move on to science or fiction.
It's time for science or fiction.
Each week, I come up with 3 science news items or facts, 2 real, 1 fake, and I challenge my panel of expert skeptics to tell me which one is the fake. We have a theme this week. The theme is everyday chemistry.
Okay.
Things in your life that you may not know some subtlety about in terms of how they work. All right, Here we go. Item number 1. Microwave ovens heat food unevenly, partly because they produce standing waves with high and low energy spots. Item number 2. Rusting is an electrochemical process with a little battery forming on the surface of iron, including an anode and a cathode. And item number 3. The gases inside bubbles of freshly baked bread prior to cooling are about 80% CO2 and 20% oxygen. Evan, go first.
Microwave ovens heat food unevenly, partly because they produce standing waves with high and low energy spots. Standing waves. Geez, I probably should have concentrated more on that particular one.
A standing wave is a wave that doesn't move, right? So have you ever taken if you have a rope, two people are holding a rope, and you get it going, vibrating at a certain frequency, where the waves are just going up and down, but there's not waves propagating up and down along the string. That's a standing wave. So it's basically you have just waves that are sort of fixed in position. They're not propagating.
Well, then this would make sense then, because you would have spottiness to something like that. You would have a high energy spot versus a low energy spot. So I don't see a problem with that particular one. Moving on to rusting. It is an electrochemical process with a little battery forming on the surface of iron. Wow, really? Including an anode and a cathode. Hadn't heard about that before. What was rusting? Rusting is what? The oxidation, and when it reacts with oxygen, and there's water, forms the rust. But is this actually... I don't know about this one. This one's a little new to me, that description. I'll go to the third one about the gases inside bubbles of freshly baked bread. Jay's going to have an advantage here. Are about 80% CO2 and 20% oxygen. Well, I guess I'll say the rusting one is the fiction. I never heard it described before as a little battery forming on the surface of iron. Is that right? Would that be right for water and oxidation? I have to guess at one of them, so I'll say the rusting one is fiction.
Okay, Bob.
Yeah, microwaves heat unevenly. Yeah, I mean, the microwaves are bouncing around, interfering. I think that interference is what would be causing these standing waves. So yeah, that makes sense to me. The third one also, these gases inside baking bread. I really wish Jay went before us, but it kind of makes sense. I don't know how that works. That seems reasonable. I really can't comment on that too well. And then we've got the rusting. I think I'm going to agree with Evan here. It could. Yeah, I don't know enough about the process to discount this possibility that it's really an electrochemical process. I mean, be interesting, but I just can't. Not sure. So I'll say that one's fiction. Maybe roll the dice here. Oh wait, I've got my coin.
Yeah, flip that.
Yep, number 2, fiction.
Perfect.
All right, Kara.
The coin never lies, by the way.
I feel like they're all science. Like these all feel like they would be science. And there's like little details in each of them that you could be getting us on. So you did say partly because they produce standing waves. So I don't think you're getting us on the fact that it's like fully responsible. And I kind of agree with Bob about the idea that like the waves are sort of like bouncing off of like all the shielding and stuff in the microwave. So yeah, we all know that microwaves have hot spots and stuff. Isn't that why they have like turntables in them? So that would make sense. I do think rust is electrochemical. I think that's interesting to describe it as a battery, but that would make sense, right, with an anode and a cathode. And then I do think that the gases inside bread, like you mean like the little that make the little holes in bread, are about 80%. I mean, I do think they're mostly carbon dioxide, right? Because this is yeast. It's an anaerobic process that by yeast respire via fermentation, which is going to give off a lot of carbon dioxide. I think maybe that one is the only one with enough specific details that maybe it's not 80% carbon dioxide and 20% oxygen. Maybe it's like a different concentration. So I don't know. I'll say the bread one is the fiction.
Okay, and Jay.
This is my Slumdog Millionaire version of science fiction.
Okay.
Microwave ovens, of course, heat food unevenly. Anybody that's used one will know, right? You guys know that, right?
I do.
Mm-hmm.
And I happen to know why. Because if I'm remembering correctly, it's not. I don't think it's the. I don't think it's the shape of the inside of the microwave or anything. I think the actual waves affect each other, and there's like high and low energy spots in a microwave. Oh, I know why I know this. Because I watched a guy remove the what do you call it, the thing in the microwave that makes the microwaves, a diode. What is that thing called? Mm-hmm. There's a component
the thing that
inside
produces the microwaves.
Yeah, that's what we call it. Yeah,
the microwave generator.
Yeah, so it had to be from
The
TikTok
Heisenberg
or something.
compensator.
Yeah, so that's pretty straightforward. Yeah, we know that there's cold and hot spots, and there's some type of interference going on. This one about rusting, it's kind of, I don't know, it's kind of weird to say it's a battery, but I mean there is it is an electrochemical reaction. That's what I know. So it fits the bill. But I mean, obviously, I know the answer to this last one here. How much detail do you want, Steve?
Just give me the bottom line.
So there's a few things that are happening here, but the vast majority of the gas is carbon dioxide, and that is, of course, essentially excreted by the yeast, who are in hyper eating production. You know what I mean? Like when they get into the oven, the temperature change. You know, yeasts are like literally connected directly to temperature as far as their metabolism goes. So when the heat goes up, the yeast go berserk, and that's where you get oven rise from, like the oven spring, where the dough goes from a small state to a larger state, because it all has to do with CO2 gas production. There's some nitrogen in the mix. It's inherent in there. It's just there's this nitrogen in the stuff that dough is made out of. And the other big player in there, it depends on the type of bread. You know, hydration level of the bread is important here with this, but the water also instantly vaporizes pretty fast, right? And that water steams out of the bread, and actually, if you're using a Dutch oven, which is an enclosed space, it steams the outside of the bread, which has a chemical reaction on the outside of the bread, which is where you get a caramelized crust effect. But oxygen is I would say oxygen is so unbelievably insignificant that we shouldn't even be talking about it. It's not a player at all. Oh. It doesn't come into play at all.
Okay, so you guys are split between 2 and 3, so we'll start with 1. Microwave ovens heat food unevenly, partly because they produce standing waves with high and low energy spots. You all think this one is science. Now, clearly, microwaves heat food unevenly. We all know that. We've been using them our entire life. That's not the part that's critical here. The question is it partly because of the standing waves? There's lots of other reasons why microwaves heat food unevenly. They heat from the outside in, right, is one part. But also, you know how microwaves heat food, right? Well,
they vibrate the water molecules.
Right, they directly vibrate the water molecules. So food has different concentrations of water in it. Even the same food will have different concentrations throughout. So parts with a lot of water will heat up much more quickly than parts with less water.
Oh God! I was heating up chicken pot pie, and every little piece of it, like the crust versus the chicken versus the peas,
it's all different.
Yeah,
all different. Yeah,
that happens with lasagna
smart,
too,
Steve.
where like the cheese is like super melty, and then like the meat part's still cold.
Yeah,
like
so the standing waves have.
Kara, I love you a little bit more because you just said that.
It's annoying though, isn't it, Jay?
But this
you gotta
one.
Let it sit. You gotta let it sit for about 10 minutes after you.
Well, that's why you're supposed to open and stir halfway and
stir your lasagna. Right. What are you talking
No, you can't.
about?
You just eat it till it melts your goddamn mouth. You know.
This one is science.
Oh, good.
Because it is also partly because of the standing waves.
Yeah.
Uh-huh.
That's why, Kara, you're 100% correct. That's why it has the little spinny thing, as you said. It spins around, so it's moving through different parts of those standing waves. Because there are hot and cold spots just in the microwaves themselves. Plus, there's the water factor. Plus, there's the outside-in factor, and blah blah blah. So,
how much could that possibly factor? The outside in, like, where are you talking about? Like,
it only
the microwave
penetrates
itself?
an inch and a half or 2 inches. So anything bigger than that, it's only heating through convection or conduction. So you know what I'm saying? It's not penetrating. That's why it's always better to cut things up, not have a big chunk of something in the microwave.
Oh yeah,
it does not penetrate
That's
that far.
Classic move.
Yeah.
Well, you want a microwave ideally that has a spinning plate inside to move through all
but
those.
But the spinning is because of the standing waves.
Oh, interesting. So
chopping it up is
specifically
because
for
it doesn't penetrate that far, and you have to stir it up in part way through. I usually will do it like twice when I'm heating something, just to help even out the distribution of heat. Yeah.
Right.
Okay, let's go on to number 2. Rusting is an electrochemical process with a little battery forming on the surface of iron, including an anode and a cathode. Bob and Evan, you think this one is fiction. Kara and Jay, you think this one is science. And this one is science.
Yeah, Jay.
Yep, this is cool. So, yeah, I know, of course, we know basically know that rust is iron is combining with oxygen, but is it just a chemical reaction? Is just the iron binding with the oxygen, or is it, as discussed here, an electrochemical process? And it turns out that it is. And it does. There is a little battery that forms because you have an anode and a cathode with electrons traveling from one thing to the next, and that's ultimately leads to the iron binding with the oxygen and forming the rust. And that's corrosion, right? So corrosion is like an electrochemical process. And water makes it go faster, and the salt water acts as like a catalyst that makes it go really fast. That's why salt water really results in rust. All right, that means that the gases inside bubbles of freshly baked bread prior to cooling are about 80% CO2 and 20% oxygen is the fiction, and Jay knew all the details. So it is...
I have more. You want?
Well, let me give you my quick summary, and if you want to add anything, you can add it, because you gave a pretty good description. So it's mostly CO2, and then the second biggest contributing factor is what?
Nitrogen.
No, it's water vapor.
Nitrogen.
No, but you can't say that, Steve,
Yes,
and
you
I'll
can.
tell you why. Because the water vapor depends on, like, some doughs are super high hydration and some are very low hydration.
But nitrogen is so small that it's always going to be less than the water vapor. It's CO2 first, water vapor second, and then a trace of nitrogen. The nitrogen's there because there are bubbles pre-existing in the dough that's just air. It's oxygen and nitrogen.
I don't think you're right.
There's no oxygen because it gets used up, right? It gets metabolized. And so there's almost no oxygen there. Again, this is right when it's done baking, but prior to cooling. Once the bread cools, what's in those air bubbles?
Air.
I mean,
Air?
I would.
It's air.
Yeah.
It just eventually gets replaced with room air because it's not
that makes
airtight.
sense.
It's porous. The CO2
Got it right because Steve said it, what's in the air bubbles. It's got to be
is air, right?
So an interesting thing here about that air is that the lack of oxygen in the baked bread actually helps it last longer because without oxygen, the microorganisms and oxidation isn't happening. That's why it's good. You definitely want to cool your loaf and everything, but don't just leave it out. If you leave it out, it's going to obviously get stale. You could put it in a refrigerator, or I freeze. I make 2 loaves. I never make 1 loaf anymore. It's always 2 or more.
And then you
I'll
freeze the one,
them.
which is fine. As long as you freeze it airtight, otherwise it gets freezer burnt.
I like that expression. Cool your loaf.
But if you guys are anybody listening to this are remotely curious, yeast are unbelievable. These particular types
Little
of
guys.
yeast that we use, they are unbelievable little machines. They have different. They can metabolize an oxygen environment. They can metabolize in a zero oxygen environment. They make CO2. They make ethanol. These are magnificent little creatures that do so much. It's really cool. When I first started baking bread, it was just you put it in the oven, you pull it out, it tastes good. It's knowing the chemistry behind it has made me absolutely fascinated with what's going on. It's just a really cool chemical process that's happening.
So one thing I didn't know, Jay, until I was researching this piece, is that before that final bake, the CO2 is largely dissolved in the dough, just like the water is. And when you heat it, the CO2 comes out of that dissolved form into the gaseous form.
Yeah, and also, like I said, don't forget that the yeast are
cranking out more at the end.
They're going berserk, and they're producing a ton of CO2, and that's where the oven rise. That's where they call it oven spring.
Yeah, but the part of the oven spring, look this up yourself because this is what I was reading. Part of the oven spring, and that's the exact term they used, is CO2 already in the dough from the yeast metabolizing up to that point, just becoming into a gas. Yeah,
and expands.
There must be a certain point, though, right, where the yeast just die because it's too hot.
They do. They die.
Okay.
They die at about, I think it's 120 plus degrees.
Okay, and then there's no more. All the CO2 that's there is there.
Yeah, but it should be enough. That's the idea.
Well, keep this in mind. They're eating the dough.
Right.
They're eating the water and the flour and the sugars. So, there's plenty of food for them to eat. So it's not that. It's not the lack of food anymore. It's a lack of they can't live in the temperature anymore. So they all die for a good damn cause.
Thank you, yeast.
Now, before we move on, Steve.
Yes.
Kara, you freaking amaze me.
How she backs into the right answer every week.
I'm always right for the wrong reason.
I'm always paying attention to you guys and where you go. It's really fascinating to me to just hear you guys, figure it out, right? But Kara, your instincts are fantastic.
Yeah, you have really good. That's true. You have very good instincts.
But you're educated enough too, where you're making really good assumptions and things like that. Like you had no business getting this one right.
But sometimes
you really didn't.
Well, if I might, I did teach bio lab for many years, and taught about respiration. But yeah, sometimes I think a little bit of knowledge really screws you in science or fiction.
Oh yeah,
I get
it does.
that a
but
lot.
you do so well, and we talk about you behind your back. Particularly Bob and I, we're always like, how the hell? Kara's just got this. You have a confluence of knowledge bases that make you really good at science.
You want to know what it is, Jay? I'm going to do a throwback here.
Reading?
Yeah.
Of course it is.
Yeah.
And I want to say one other thing, too. Today on the live stream, we were talking about how most people don't have expertise in anything, right?
Or you have it in one thing, but you don't have it in most things.
Of course, yeah. The vast majority of knowledge out there, you don't know anything about.
Right.
And I'm proud of myself for sticking with this hobby for as long as I have and really absolutely falling head over heels in love with bread and the bread making process and all that stuff. And I do feel like I'm entering a zone where I have a little bit of all right, I know what I'm talking about. Mm-hmm. You know what I mean? It feels good. It's empowering. I feel like I want to share my knowledge and teach people and, tell people how cool it is and everything. So I highly recommend pick something in your life and get really good at it. Get really good. Understand it upside down and backwards.
Yeah, I tend to look at knowledge as a pyramid. It doesn't have to be a single peaked pyramid, but get really, really good at one thing, but get somewhat good at a moderate amount of things. And baseline good at a lot of things. Because everything has a steep learning curve at first. Just get over that initial steep learning curve and you get 90% of the way there. You're not an expert or anything, but you know enough to know that all the things that most people think about that topic are wrong.
Yeah.
You learn about all the myths and misconceptions and all the fact that TV completely misrepresents it. You get that in that first initial steep learning curve. So just be curious about as many things as you can.
It's also the same with skills. You don't have to be amazing at something. You have to be good enough and you'll be able to do a lot in this world. I think we've talked about this and I'm going to say a word that's going to make all of you say a word after. So I'm just going to do it. So when I do my knitting...
Every
time. Whenever I am knitting, I all I know how to make is a scarf. Yeah. I know conceptually how to increase and decrease stitches and how to cable knit and how to do all these cool things. I don't want to practice it enough to get good at it. But I'm good enough to just make a scarf, and that pleases me. That's all I need to be able to make in this life.
Yeah. I'm currently doing a deep dive on bamboo. Because I have a stand of bamboo in my backyard, and I had to cut some of it down. I'm I'm going to do something with this bamboo. So I just finished building a segment of fence out of it.
Oh, cool!
And now, when my current crop of bamboo has dried out enough, I'm going to start heat treating it. I'm going to level up to the heat treat skill, and just do cool stuff with it. Because why not?
Love that.
Yeah, it's fun. All right. Embrace the analog world. We can't live our lives in the digital world. Evan, give us a quote.
I should have gone against the grain.
Nice.
Thanks, Bob. See? Get good at one thing. However profoundly we may penetrate the depths of space, there still remain innumerable systems, compared with which those which seem so mighty to us must dwindle into insignificance or even become invisible. And that was written by Mary Somerville. This quote was suggested by a listener named PK, who actually wrote us back in 2022 with this quote. And PK says, maybe you've covered Somerville before. She was a brilliant scientific mind for whom the term scientist was literally coined, since man of science didn't include her.
Oh. There was man of scientist before her. That is awesome.
That's weird. Oh, fascinating.
Isn't that?
Yeah, it's awesome in a very disturbing way, but...
Yeah, it is.
For her, it was only men of science. Oh,
she was born in 1780, died 1872, was a Scottish scientist, writer, and polymath. She studied mathematics and astronomy, and in 1835, she and Caroline Herschel were elected as the first female honorary members of the Royal Astronomical Society.
Nice.
Very cool.
A polymath,
Very
see?
cool.
That's what we're talking about.
Yeah, we were, yeah.
Be really good at one thing, but also be a polymath about a lot of things.
There you go.
All right. Thank you, Evan. And
you.
thank all of you for joining me this week.
Thanks, Steve.
Of course.
Thanks, Steve.
Sure, man.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.